Good morning and welcome to this class. This is Neselifa Academy. In today's tutorial video, we shall be solving some problems on electromagnetism. Basically, we shall solve 3 problems. You can check our previous video on electromagnetism and see for yourself. If today is the first time of visiting our channel, take time to go through our playlist to see the videos we have made. And if they interest you, you should give us a subscribe. Subscribe to the channel for updates. We do videos on mathematics and sciences. And you can always comment on the areas you would want us to treat for you. We also do assignments for students. We also write projects for students. So today, we have 3 problems before us, as I have said, and we'll begin by solving this problem that has to do with Kirchhoff's law. The question says 2 cells A and B of EMF 2 volts and 7 volts respectively are connected positive to the cells, which are connected to an external resistance 10 ohm. If the internal resistance of A is 1 ohm and that of B is 2 ohm, calculate the current in the circuit. Calculate the current in the circuit. So solution to solve this, we begin by making a diagrammatic representation of this. So 2 cells are connected positive to positive. This is positive. This is symbol for cell. Positive to positive should be in this case. You have another one here. So these are 2 cells. They are connected what? Positive to positive to an external resistor. This is the symbol of what? Resistor. Okay. Connected to an external resistor of how many ohm? Connected to an external resistor of 10 ohms. So this is an external resistor of what? 10 ohm. So this is what? 10 ohm. And these are cell A and what? Cell B. And we are told that cell A is 2 volts and cell B is what? 7 volts. And each of them has 1 ohm internal resistance. So if the internal resistance of A is 1 ohm and that of B is 2 ohm, so internal resistance for this, we still draw symbol for resistance. Internal resistance of this is 1 ohm and internal resistance of this is 2 ohm. Okay, so the question is calculate the current in the circuit. So this is a Kirchhoff's law problem, and in this problem we just have a single loop. Look at the loop. If we are to label this, this is A, B, C, D. We just have 1 loop. Okay, so we want to find the current in this circuit. Of course, the same current will flow in the circuit because we don't have what? A defined junction. We don't have a defined junction. And since we have 2 sources of EMF, we shall employ Kirchhoff's law. And of course, Kirchhoff's voltage law, the second law, which says that the sum of the voltages in this circuit that should equal 0. You can always state it that the sum of the potential drop and the potential across the circuit elements, that they should what? Equal what? 0. So we shall see how this applies. So if you have not watched our video on Kirchhoff's law, you should check our playlist for proper understanding of this. So we'll choose the direction we're going to follow. Let's follow in the direction of the current. So when we are moving from the negative side of the cell to the positive, we have a voltage lift. So the potential here is positive, so you have 7 volts. And when we are moving in the direction of the current and we meet a resistor, we have a potential drop. So from Ohm's law, V equals IR. And since the same current is flowing, we just have minus 2 what? I. We keep going. We meet a source of EMF again. So this is the positive side of the cell. When you are moving from positive to negative, you are moving downhill. So you have a potential drop too. So you have minus 2 volts. So you have minus 2. And we are still moving in the direction of the current. So we'll have a potential drop here. So have minus 1, okay, I, because we are following what? Ohm's law. The resistance here is 1 ohm and the same current flows. Similarly, of course, that's why we have I here. So meeting this resistor again, still in the direction of the current, you have minus 10 what? I. And everything should what? Equal 0. This is the law of conservation of energy. So what do we do again here? We say 7 minus 2 is 5. This is minus 2 minus 1 minus 10 is minus 13I. So everything should equal what? 0. And when you make I subject of the formula, you'll be having that this cancels. I equals 5 upon 13. And 5 upon 13 is approximately 0.38 ampere. So in the problem, this is the correct option, the correct answer. So the current that will flow in the circuit is what? 0.38 watts ampere. All right, let's continue. I believe you understood the first solution. As I have said, if what we are doing here interests you, do well to subscribe for more updates like this. Of course, it's going to help you if you are still a school student, and you can always share it with your siblings and junior ones. So let us solve this problem 2. It says that a flat circular coil, let's say the coil is this, is circular, don't mind the diagram. A flat circular coil has the number of loops, okay? I won't keep drawing it. Let's say the number of loops is 40, and it has diameter. Diameter is 32 what? Centimeter. What current must flow in this wire? Let's say this is a coil of wire, okay? A loop of wire having this coil. All right. So what current must flow in each wire to produce a magnetic field of what? To produce a magnetic field of 3.0 times 10 to the power minus 4 Weber per meter square. This is Weber per what? Meter square. Weber per meter square is the unit of magnetic field strength. So to solve this problem, we shall be making use of the Biot-Savart relation for a current or circular loop. The Biot-Savart relation for a current or circular loop is given as B equals mu naught N I upon 2R, where mu naught is magnetic permeability. This is magnetic permeability. So you should not misconstrue this with permittivity, which is always written as this. So what we are talking here is what? Magnetic permeability. It has the value of 4 pi times 10 to the power minus 7 Henry per meter. And N is the number of what? The loop. We have 40 loops. So you can see the number of turns. N is 40. And the current is what we are looking for. The current, we don't know it. The R, we can get it, the radius, we can get it from this diameter. Of course, we know that radius is diameter upon 2. So how did we come about this formula? This formula came as a result of the expression from the Biot-Savart relation for a current loop or a circular current loop. Let's see if we can quickly prove this. So to prove this, let us see this as a circular loop or a current loop in which current is flowing. In which current is what? Flowing. Let us define an infinitesimal length and call it what? The L. If the current makes angle 90 degrees, if the current flow makes angle 90 degrees with the radius, and as the current is flowing, there exists magnetic field. So we can have an infinitesimal magnetic field too. So we want to find the expression for this magnetic field. So, and how do we define it? If you look at this, the circumference of a circle is 2 pi r. And this is just the infinitesimal area of length, infinitesimal length, sorry. So to find the L will just be the circumference of this circle times the number of loops or the number of turns. So that will be L. And to find B, we integrate from 0 to what? L. Okay? This is how we can find B. And what is this L? This L is 2 pi r what? N, which we have found. And B, the B is giving us, this is the Biot-Savart relation we are talking about. This is mu naught upon 4 pi I, the L, sine theta upon what? R squared. So this is the Biot-Savart relation. So if we now integrate this, we have 2 pi r n. So instead of having the B, we shall be having mu naught upon 4 pi. This is 4 pi. We have I, the L, sine. In this case now, we shall be having 90 degrees because the theta is 90 degrees. We have sine 90 upon what? R squared. R what? Squared. So going further, our interest is to differentiate this infinitesimal area of length. So we bring this out. We have mu naught I upon, this is 4 pi, okay? We have r squared again. Then we integrate from 0 to 2 pi rn of the L. That is what we do now. And if you perform this integration, you have that B is, this is mu naught I upon 4 pi r squared. So this now will be, integrate this, you have L, you have 2 pi r n. So when you cancel like terms, you have that B is mu naught Ni upon what? 2R. So this is the magnetic field strength for a circular coil or a current loop. So this is very important. Before you calculate the magnetic field or use expression for the magnetic field for a particular concept, you should know what they are talking about in the equation. For instance, if it is a solenoid, if it is a straight wire, it will not be the same formula for magnetic field strength. So let us go further to use, our interest is in the use of the formula, not the derivation anyway. All right, going further. So for a circular or current loop, we have that the magnetic field strength is mu naught Ni upon what? 2R. So our interest is to find the what? Current. What current must flow. So let's make I the subject of the formula. I have mu naught Ni equals 2BR. So if we make I subject of the formula, you have 2BR upon mu naught what? N. And let's write our B again. B, which is the magnetic field strength, is 3 times 10 to the power minus 4 Weber per watt meter square. And the diameter is radius is diameter upon 2, and this is 32 upon what? 2. You have 16 cm, which when you change to meter, you have 0.16 what? Meter. All right. So going further now, of course, we know that N is what? 40. N is 40. And mu naught is the permeability of free space. You have 4 pi times 10 to the power minus 7 Henry per what? Meter. So replacing in this problem, in this formula, you have that this is 2 times. This is the R is 0.16, and the radius is the radius is the R, okay, and B is giving us 3 times 10 to the power what? Minus 4. They have upon the magnetic permeability is 4 pi times 10 to the power minus 7 times the number of turns is 40. So once you do this, you have 6 upon pi, and this is approximately 1.9 ampere. So option C is the correct answer. So this is the current that must flow in the wire to produce this magnetic field at its what? Center. Again, don't forget to give this video a like and comment on the area you would want us to treat next, and subscribe for more updates. All right, let's go for that. Problem 3 says an electron is accelerated from rest through a potential difference of 800 volts. So potential difference of what? 800 volts. It then moves perpendicularly to a magnetic field of, the magnetic field is 30 Gauss. 30 what? Gauss. Find the radius of the orbit. So if it's moving and is orbiting, how do we find the radius of the orbit? Okay, of course, remember that this is an electron. This is what? An electron. And of course, as it's moving, it's having kinetic energy. And formula for kinetic energy is half mv square, and of course is equivalent to electron watt volts. So this is expression for energy. Another expression for energy, charge times what? Potential. Charge times potential. So we can of course, let's find expression for the velocity, because what we know now is the potential. So we can say mv square equals 2 times this, 2 times electron watt volts. This is just like saying charge times what? Potential. So when we make v square subject to the formula, you have that this is 2 electron watt volts upon what? M, where this is the charge of the electron and this is the mass of the electron. Let's make something clear here. We know that 1 Tesla is 10 to the power 4 Gauss. 1 Tesla is 10 raised to the power 4 Gauss. So 30 Gauss, what will it give us? 30 Gauss will give us 30 times 10 raised to the power minus 4 what? Tesla. An electron, the charge on an electron is 1.6 times 10 raised to the power minus what? 19. And the mass of an electron is approximately 9.11 times 10 raised to the power minus 31 kg. So if we now find V here, V will be square root of this. V will be square root of 2 electron what? Volts, okay, upon M. And this will be square root of, this will be 2 times 1.6 times 10 raised to the power minus 19. The potential is 800 times 800 upon the mass of the electron is 9.11 times 10 raised to the power what? Minus 31. Once you do this, you have 16.76 times 10 raised to the power 6 meter per second. So this is the velocity of the electron. The velocity of the electron. So we shall be making use of this to now find the radius of the orbit. To find the radius of the orbit, if the electron is moving around the orbit, the force, okay, the magnetic force is being provided by the centripetal force. So, and since it moves perpendicularly to the magnetic field, it expresses a maximum force. So that we can have that the maximum force QVB equals the centripetal force provided by the what? The electron is moving. So one of these V's can what? Cancel. And if it cancels, you have that QB equals mv upon r. So we can now quickly find the radius of the orbit from this, employing this formula. R equals mv upon what? QB. And we now have, this is the mass of the electron. So you have 9.11 times 10 raised to the power minus 31 times the velocity of the electron. We have evaluated it before. Have 16.76 times 10 raised to the power 6 upon the charge of an electron is 1.6 times 10 raised to the power minus 19, and the magnetic field strength B we have evaluated before, 30 Gauss, which is equivalent to 30 times 10 raised to the power minus 4. So once we do this, we have it to be 0.03181 meter, and this is approximately 3.2 cm. Once we multiply this by what? 100, we have it in what? Cm. So option A is correct. So the radius of the orbit is 3.2 cm. Thank you for watching this video, and do well to subscribe for more updates like this. We do videos on mathematics and sciences. This is Neselifa Academy, and we are signing out.